We'll start up with the third program. That is, the question of your program says, draw a color cube and spin it using OpenGL transformation matrices. As I told, check out, this should be your output. As I have given in the question, as the question says, OpenGL transformation matrices. These transformation matrices basically works with respect to access. As in the morning class, we started and studied something called as three different axes, right? With the help of which the transformation works. So these are the different axes. So this is the if you represent the cube in x-axis with the help of rotation, if you want to perform rotation on the cube in x-axis, so this should be your output. If you want to perform rotation through y-axis, this should be your output. And similarly, with respect to z-axis, this should be your output. So this is the basic output of your program. So this is the question. So we'll check out how this program works. How should we evaluate that cube so that we can represent each of the cube in different axes. Then I have defined the algorithm here. This is the basic flow of the program. I can say how to perform and display a cube and perform spinning on that particular cube. So we'll check out how the algorithm's steps moves. The first step is start. You will start the program, and then step 2, render the cube using the array of vertices. You will define 3 different vertices here so that the cube is being represented in 3 dimensions with the help of vertices. This is the second step where you are performing some array of vertices so that you will display that particular cube in 3 dimensions. Then obtain the coordinates of the cube with the origin at the center of the cube. As I told, the cube should start spinning or rotating in its origin with respect to some angle. Once the rotation is done, there to perform that operation, before that you need to know the coordinates of that particular cube. What are the coordinates? I can say x0, y0, x1, y1, so on. These are the coordinates, right? If you want to define a cube, so you should first obtain that particular coordinates so that you can perform spinning as well as rotation on that with respect to some origin where the center is being applied to that particular cube. Then I should draw the faces of the cube using different 3 points. That is nothing but, you can check out in this, there are a number of cubes here. There are 3 different cubes. How many faces does a cube have? It will be having 6 different faces. This is the first face, second, third, the back one is fourth, the side one is fifth, and the bottom one is sixth. I can tell these are the 6 different faces, not PHACS, it is faces, FACES, okay? The 6 different faces of the cube. Once I'll calculate the center of the cube with the help of coordinates, I should start drawing the 6 different faces of that cube. Once you have drawn 6 faces of the cube, you should start incrementing the angle. As I told, what is the important aspect of the rotation? It is nothing but the angle, right? Whatever the angle you specify, you should start incrementing with respect to some axis. There are 3 different axes, x, y, as well as z. With respect to that axis, wherever the cube is being displayed, the current axis, you should start incrementing the angle there by giving some value. Once you start incrementing the value of that particular angle with respect to the different faces, you should start displaying the cube onto the screen and start rotating it by the current value of the angle with respect to some axis. As you keep on incrementing the angle, you should start displaying that particular cube there. Then you should repeat these 2 phases. That is, again, you'll find out the 6 different phases with respect to different rotation. As I told, the cube should be rotated and spin with respect to 3 different axes, x, y, as well as z. While you increment this particular angle of the cube, when the step is done, the cube will be displayed in all the 3 axes, that is x, y, and z axis. So with respect to, when you start repeating this 4th and 5th step, you will get the cube in all the 3 different axes. Then once you repeat this 4th and 5th step until mouse event occurs. That is nothing but till you enter a mouse key, whatever the mouse you are using. If you enter a mouse or a keyboard event, till then it will keep on rotating the particular cube and start spinning. Once you press any key, it will stop spinning or rotating that particular cube. So this is the flow of the code. This is the flow of the program, I can tell. Where first you will start rendering the cube with the help of vertices. You calculate the coordinates as well as center of the cube. You will draw the faces of the cube. Then you will find out as you give some angle for rotation, you will start incrementing that particular angle. Then display the cube on the screen. Then you keep on repeating this fourth and fifth step until some key is not press, then you will finally end up that particular code. Okay, is the flow correct to all? Is the algorithm clear to everyone? Is the algorithm correct, students? Is did you people understand the algorithm, the flow of the code? Yes, no, yeah, okay. So we'll start up. Then I have explained this, the basics of this in the morning class. We'll check out how the 3D coordinate system works. First of all, what are 3D coordinates? Basically, you consist of three origins, not origins. I can say axis, that is x-axis, y-axis, as well as z-axis. With respect to that, I will define some origin, that is O here. These are some of the vertices I can find out with respect to that particular axis with one origin. Suppose there are two systems with respect to 3D coordinates. One is right hand coordinate system and the other one is left hand coordinate system. If you implement right hand coordinate system, check out the shape. If there are three axes, x, y, as well as z. For example, if you keep your hand in this stage, check out the diagram here if it is visible. If you perform or place your hand in this position where the between finger, whatever this is the thumb, this is the next two fingers. If you place this first finger in this phase, it should come in the form of y-axis. If you perform this phase, the thumb, if you place, it should come in x-axis. This will come under z-axis. So this is called as right-hand coordinate system, where a 3D object is displayed with respect to x, y, as well as z-axis. Coming on to the next part, that is left hand coordinate system. If you place your left hand in the form of this axis, three different axes, you'll get just x, y, and z, whatever the object you want to display in the 2D format. So these are the coordinate systems with the help of which you can perform different coordinate systems such as 2 dimension as well as 3 dimensions. In our application, as we are using OpenGL, basically OpenGL uses this kind of format, that is nothing but right-hand coordinate system, where different applications such as Direct 3D, Swan, there are different applications which use these kind of coordinate systems with the help of which they will display the particular object. But check out whatever the object, whatever the output you want to display is similar in both the cases. Okay, if you are using right hand coordinate system or if you are using left hand coordinate system. So this is just for your reference to, you should know if you are using what kind of system. If you are using different applications, you should be knowing in 3D format what and all will be used and what are the kind of system you will be using in that particular coordinate systems. Then we'll start up with the program. As we all know, we have some preprocessor directives as well as some libraries to be defined. Two different libraries, preprocessor directives I have defined, Studio as well as math.h, because I'll be using some functionalities with respect to that directive. Then I have defined a library called gl/glad.h. Then I'll define some coordinates. As I told, what is the first step? The first step is nothing but you'll define the vertices of that particular cube. How many faces I told the cube will have? Six different phases, right? With respect to six different phases, you'll calculate the vertices. You will define some of the vertices here. For this vertices, basically you need some coordinates. I have defined three different vertices which consist of an array. I have defined a vertices which is of an type array. I have defined that particular vertices here. So of kind floating point value. Then I have defined something called where rotation is being performed. Uh, that is three different axes. As I told, we are, then I will define a variable called as int x. That is nothing but with respect to some rotation axis, what is the default value for that? I have defined it as ax, which is assigned as 2. So these are some of the variables I have defined here. Then check out with respect to some axis, there is something called as different values given to this. How this values varies 0, 1, 2. If you, as I have defined 2 here, why I got 2 here? Why not 0? Why not 1? Hope I'm audible, students. You don't have any issues, right, regarding my voice?
No, sir.
No, sir.
Yeah, okay. So as I told, I should define some different axes with respect to which I need to define the object. With respect to that, check out here. 0 is x-axis, 1 is y-axis, and 2 is z-axis. I have defined the z-axis rotation here. So how we will get this z-axis rotation, x-axis rotation, and y-axis rotation? We'll check out in the next slide. If it is 0, what is the values? -1, -1, -1. So how did I get this particular coordinate values here? If it is 0, check out here, all the values should be negative. Where I will get the negative value? In the z-axis, right? So this is the value where you need to define the three different objectives of that particular axis. Check out here, this is a positive, positive, and positive. This is with respect to the two-dimensional object. If you are defining 0, check out here, what is the x-axis? Whatever you have defined, it is in the x-axis. I have defined it as 2. Let's check how 2 is defined. 1, 1, and -1. Check out what is the 2th axis. I can tell it is the z-axis, where the values I have got as 1, 1, -1. What is the where I have got this particular value? In this format, that is nothing but z format. This is just the representation where you are defining the cube. If it is in the x-axis, if you are defining it in the y-axis, or if you are defining that particular cube in the z-axis. So this is just the representation I have defined here with respect to the cube. So check out, how did you get, this is the performance evaluation of that particular coordinates. For 0, x, y, z, with respect to all the values for x, y, and z. This point is in z, so it is given with respect to 1. X and y, I have defined it as -1 because the coordinates are not lying in that particular axis. With respect to the first, I have defined this as first coordinate. This is in the format x, y, z. This lies under both x as well as y axis. So these values are 1. The rest is -1. Check out if this is fifth, x, y, z. This point lies in the x axis. I have defined x axis as 1, and the rest y and z axis as -1. Similarly, all, check out the origin point. This is the point where it is connected to all, where it is not connected to all, where x, y, as well as z is not yet defined here. So I'll be defining all the point as -1, -1, and -1. So this is how you'll get this particular values here. Then we'll check out, as the program execution starts with main, we'll check out how the main program works. As in all the programs, I'll be defining the main function with two arguments. One is argc as well as rv, which is an argument count, as well as we are using argument vector. Then I will initialize the glut library here with the similar arguments. Then check out a comment given here where we need both the double buffering as well as Z buffer. When you start and execute this command, that is glut init, it basically tells you are using what kind of buffering, what kind of buffer is used. That is two-dimensional buffer. If I tell double buffer there, then what is the name of that buffer? The name of the buffer will be Z buffer. It is all the functionalities which we'll be using will be stored in the Z buffer. Then we will initialize the display, that is nothing but the window, that is glut init display mode. This basically tells what kind of mode you are using for that particular display, where what kind of buffering, the depth of that particular window, and we will be using different colors as well there. So I'll be defining RGB, the type of buffer, the depth of that particular buffer with respect to this particular command. Then I should set some window position as well as window size. So with the help of these two commands, I will set the position as well as window of, set the size as well as position of the window. Then I will name the window as cube rotation. The window name will be, once this command is executed, a window is being created of name cube rotation. Then I will go to, I have defined init function here. So we'll check out what init function does. Void init. In init function, basically you will define the type of matrix mode, and you will assign that particular matrix to orthographic projection. Check out the type of matrix mode will be GL projection. Basically, what does this basically tells what kind of primitive you are using. I have defined the orthographic projections with respect to all the axes here. Then what does this GL model view does is it basically tells where the object should be inserted. It will basically gives the location of the object with the help of GL matrix mode, that is GL model view. It basically tells the dimension. I can tell what kind of model you are using with respect to init function. So that is all about init function. Then we have done with init function. Then I have defined the display function, that is blood display function of display. We'll check out what display function does. We came to the display function. Check this particular diagram where all x, y as well as z axis is being represented here. In the x axis, how the rotation is done. In the y axis, how the rotation is done. In the z axis, how the rotation is done. This all rotation basically happens in anti-clockwise direction, I can say. Then the x, y as well as z, all the rotation is in the form of anti-clockwise. Check out in the display function, that is void display. First, I will clear all the buffers as well as colors. The initial buffer as well as color is being cleared, that is set to normal first with the help of this command GL color buffer bit, GL depth buffer bit. Whatever the buffer as well as color is been assigned to the window, I will give a normal. I should give 0 for that. Nothing is being included here. Now everything is empty. Once we execute all the next further commands, the colors, angles, and all will be inserted to this particular GL color buffer bit as well as depth buffer bit. Then I will give the background color as 111. What happens if I give 111 and all? I'll get the background color as white there. Then I will load the identity matrix where all the transformations, that is rotation, scaling, and so on, all the different transformations will be performed and set with respect to this particular command. Then as I'm performing rotation operation with respect to this particular cube, I'll start defining rotate here, GL rotate here. You can check out the comment line here. It tells it is rotating the cube at an angle of 0 degrees with respect to vector x, y, z. That is nothing but with respect to x-axis. I am rotating the cube with respect to some angle, that is 0 degrees. I can define the angle here with respect to x-axis. Check out, I have defined the 3 axes, x, y as well as z. I am rotating the cube with respect to x-axis. Similarly, with respect to 1 degree, I am rotating the cube with respect to y-axis. Similarly, with respect to z, I am rotating the cube with respect to this particular degree, that is 2. Then I have called a function named color cube. What does this color cube does? It basically calls the functions to color each square of cube with different colors. As I told, what is the second step? Once you have drawn the cube and start rotate that particular cube, you should color the cube with different colors. We'll check out how to color the cube. check out. This is a simple functions where this is a simple function where you are using two particular parameters, not parameters. I can tell two different command, GL color as well as polygon. I will use the function called color cube, where this is used to color each face of the cube separately. That is nothing but this. I am coloring this as differently, this as different, this as different. So I'll use to these command to color the cube GL color 3F with respect to X, Y, and Z. With respect to this, I should define some polygon, right? This is a polygon. If there is a polygon displayed, only if the polygon is displayed, I can color that particular polygon. I should define that particular polygon function inside the color cube function. So let's see what polygon function does. In polygon function, basically, we'll draw one face of a cube at a time. Suppose this is the whole cube. Check out the example given here. This is the whole cube. With the help of this polygon function, I should define each and every face of that particular polygon. Once I combine this, all the faces of polygon, I can tell a whole cube is formed. So that I have defined a function called void polygon, which consists of variables A, B, C, D as parameters of type integer, with the help of which I'll draw the square using polygon. Four coordinates of the square faces, that is 1, 2, 3, and 4, with respect to three values X, Y, Z, which denotes a point in 3D plane. This point basically tells you are defining a cube of four faces or four coordinates, 1, 2, 3, 4 coordinates with all the three axes, that is X, Y, and Z. So we'll start drawing the polygon with the help of GL. Begin GL polygon. This is type of primitive you are using is GL polygon here. With the help of GL vertex, that is nothing but floating point value, I will define all the four coordinates of the polygon, that is square A, B, C, and D with the help of GL vertex 3FV. Basically tells you are defining a polygon or a square with the help of four coordinates. So this is now I have drawn a polygon with the help of this function. Now I have a square. Once you have drawn a square, I should start coloring this square. So we'll check out the coloring function. Void color cube. This is the function I have defined here. I saw how to draw a cube now. Till this function, I can tell the cube is drawn already now. Now I'll start drawing this particular polygon. Whatever I have drawn the polygon, I should start coloring that particular polygon. GL color 3F011, that is XYZ value, Y and Z. I should start coloring in the Y and Z axis. The first polygon, the first face of the polygon is colored 4, 5, 6, 7. 4, 5, 6, 7 is colored. That is the back face. Similarly, next polygon face in this basically represent the axes XYZ. Here only Y, here only X, here XY. Similarly, all the combination is being covered here with respect to the polygon. Each and every face is being colored with respect to that particular object with the help of all of these functions. You can just check out here. These are the points which is being mentioned with the help of which the color is done. Check out if GL color 3F011 is given. What is the value? What is the value of this? This is RGB value, right? So with the help of this function, RGB value is set here where R, G, and D, G and D, green and blue is being combined with respect to this particular polygon. Now, similarly, all the points, all the faces, all the different 6 faces of the cube is being colored with respect to color cube function. Now let's see, once the color cube function is done, what happens? I will swap the buffers. Once swapping the buffers, I will put the whole display function into the loop. Once the display function is done, we'll check. We have finished with all these functions in the previous function itself. Once you start displaying the cube, now what is the next step? You need to start spinning the cube, right? What do you mean by spinning? What happens in spinning? Can someone tell what spinning is? Hmm? Or you don't know the meaning of spinning?
Rotation of cube.
Yeah, one is rotation. I can tell spinning is rotation, and the other name of spinning I can tell what I can tell reverse. Reverse. If I tell, yeah, reverse action of the particular action done initially. Right. What happens if you throw a ball on a wall? What happens? It will spin, right? Spin and comes back to you, right? I can call that as spinning. Can I tell that as spinning? Yes, no, no. Can someone give me an example of spinning? Huh? No, okay. I can tell. Suppose I will take the program example only. That is a cube. You want to spin a cube. What happens in spinning a cube is you will be able to check out all the phases of that particular cube with the help of spinning. If suppose if you are not using the spinning cube function, whatever the display output, whatever the output you get onto the screen will be in a constant phase. That is, you'll just get the 2D object. If you are using the spinning function, you can perform 3D operation on that particular cube where you can see all the 6 phases of the cube in different colors. So spinning of a cube is very necessary in this particular program. This is one of the part of the program. So we'll check out what spinning cube works, how spinning cube works. We'll check here. Spin cube basically works on only when you define on in which axis you want to spin that particular cube. We'll start with spinning the we'll start with the function spin cube. Then I will start rotating the cube by 1 degree at a time on the given axis. Suppose I should spin the cube in x-axis, I should give 0. If you want to give, if you want to spin the cube in y-axis, I should give 1. If you want to spin the cube in z-axis, I should give 2. Now I want to spin the cube in y-axis, so I am giving it as 1, where this t of ax, I have defined it before in the main function, which tells what does this t of ax tells. It basically tells the translation operation where you are performing rotation with respect to y-axis. Then we'll check the condition. If this particular t of ax is equals to 360 degree, that is nothing but the rotation with respect to some axis reaches 360 degree, I should reset that particular t of ax to that particular 0. That is the first x-axis. Check out the comment. When the rotation along any axis reaches 360 degree, reset the axis to 0. 0 is nothing but x-axis. Then again I will check once this function is taken as true, then I should give the value of t of ax is equals to t of ax minus 360 degree. That is nothing but 360. I now once this function is true, I should keep on checking for this condition where t of x is equals to 360, or else I should assume that particular t of x is equals to t of x minus 360. Then I will call the display function again once you start the spinning of the cube. Now the cube is already spinning. Then spin cube is done. Then display was done. We saw how spin cube works here. Once spinning of cube is done, now you need to stop the program, right? You cannot keep the output screen for longer time. You need to stop the program at some point. So I have defined glut mouse function there. We'll check out what glut mouse function does. In glut mouse function, I have called a callback mouse function here, where I am selecting some different axes where to rotate here. So that is, I have defined some variables here with respect to BTN state as well as XY of type integer for this particular mouse function. Check out. On left click, state of the left button is set to down and AX is equals to 0. That is, the BTN is basically the button as well as state of that particular button. I'll check that particular command condition where I'll perform rotation along x-axis. If BTN is equals to glut left button, if the button is equals to the library function with respect to the left button and the state of the button is down, then the axis should be x-axis. On middle click, state of the middle button is set to down and axis AX is equals to 1. That is nothing but with respect to Y axis, I am setting that particular mouse. If the button, or if the button will be equal to glut right button and state will be equal to glut down, I should define that in the form of Z axis. So we are using this particular glut right button as well as glut down in the form so that I can display all the mouse functions and perform clicking operations with respect to that particular cube. This basically tells whatever the button you press, if it is matching these condition, it will tell where the cube should be spinned in x-axis or y-axis or z-axis. So these are the three conditions we see in mouse functions. Once all the three functions are called, I will enable the testing where testing of that particular depth buffer as well as removal of some surfaces with respect to the displaying object is done with the help of GL enable GL depth test. Then I will put the main program into a loop and then I will start. I will return 0 here. Why return 0 here? We'll check that out. Once you perform return 0, what does it tell? If not that the case, just a second. Okay, yeah. Once I perform glut main loop, the whole program is put into loop where all the functions will be keep on executing till what is the end statement, end condition. You should press the mouse button. That's it. And to press the mouse button, the program ends its execution. Now we'll check out the output of the program. As I told, the initial stage here, the first stage is you are just displaying the cube. The second stage is coloring of the cube. The third stage will be spinning of the cube. This output basically will get the spinning cube usually. I have just represent the output in three forms. The first form is just displaying of the cube, coloring of the faces of the cube, and the third will be spinning of the cube. So this is all about the